In this section, we're going to learn about matched or paired samples, which is probably one of the most popular ways of doing hypothesis testing. You want to see if a change has taken place, whether it's your diet program works or your lesson increased students' learning, whatever it may be. You're going to do something to test the person before and after, and then compare those before and after results. So they are paired. I'm not going to, let's say I'm one of the test candidates and Junior is one of the test candidates. You're not going to mix up my before test with Junior's after test and vice versa. You're just not going to do that. You want to compare my particular tests together. But you want to do it for enough of people so you can get a nice range of data so you can see if the fitness program works or the diet program works or whatever it may be, that change did take place. So when using this hypothesis test, you want to be careful that you do have a random sample, that your sample size isn't too small. Sometimes it is small, but not too small. The two measurements are drawn from the same pair of individuals. That's what I mean why you match up my before test and after test. You don't want to compare my before test with someone's after test. That's going to give you faulty data. The differences are calculated from the matched pairs, and the differences from the sample are used in this hypothesis test, not the actual test values, but the differences. And then either the match paired have the differences that come from the population is normal, or the number of differences is sufficiently large that the distribution doesn't matter to be normal or not. Because remember, central limit theorem says if we have a large enough group, somewhere in there it's going to be normal. Here is our test statistic, but again, I'm going to really focus on the technology to be able to run this test statistic. So most of the work, the calculation work, is going to be done by, one, I'm going to show you on a website, and secondly, I'm going to show you by using TI-84. All right, so let's take a look at an example. Study was conducted to investigate the effectiveness of hypnotism in reducing pain. The result of randomly selected subjects are shown. The lower the score indicates less pain. The before value is matched with an after value, and the differences are calculated. The differences have a normal distribution. Are the sensory measurements on average lower after hypnotism? And we're going to test this with a 5% significance level. Now I have data, so I'm going to use this data to run my test. So using TI-84, I'm going to put it in list. Using a website, I'm going to put it in a list as well. I'm not going to do any calculations before. I'm going to let the calculator do all of that for me. I'm back at Statistics Kingdom, and I did find a 2-sample t-test, but I wanted to make sure that it is a paired t-test. So I just wanted to make sure by clicking on this paired data that it is the correct statistic. So when you're looking for your type of test, make sure that it is a paired t-test. And you can always check to make sure that it's the correct test statistic. So let me scroll down and check out my data, and I'm going to enter my sample data here. I do want to make sure that my alpha is the alpha that I want. My alpha is at 5%. I'm not worried about outliers. I'm not worried about effect size, and I'm going to assume that no change took place from the before and after. I'm going to assume that it's all the same. So my differences is 0. Now let's put in the scores for the before. It is exceptionally important that if I put in this data, I have to put it in the correct order in which I'm given, because with the before there is going to be an after, and those two things need to align. So I am going to put in all of the before values. So I just wanted to show you they have to align. Okay, now that I have all of my data in, I'm going to go ahead and say calculate. So I've had all the data, double check that your data aligns, and say calculate. Okay, minus after before, it does give me the averages of the difference is a drop of 3.125. I have in sets of data, number of pairs. My standard deviation of the differences is 2.9. It is slightly skewed. It's a little bit asymmetrical. It's along the left or negative skewed, but that's okay. And I'm going to scroll down, and those are all great to know, but really here is the power. I want to know what my result is. My p-value is 0.0189. That is less than my alpha, and therefore H0 is rejected. H0 is saying that they're not equal, right? H0 says, oh, the pain before is the same as the pain after, that there is no difference. But we're rejecting that idea. So we are saying that after hypnosis, there is enough evidence to say that the pain was decreased. Okay, now let me show you what it would be like using the TI-84 Plus. I am going to clear out my list, so I do need to go to Stat, Clear Lists, and I'm going to clear both my L1 and my L2 because I need both of those lists. Now that I have my list cleared, let's go back and enter our data. Okay, pop back into L1, and I'm going to key in all the data. There is one more step that we need to do because we need to find the differences of each value in L1 and each value in L2, but I don't want to do the work. I want to make the calculator do the work. So I'm going to get out of my lists, just go right into my normal area, and I want to say second L1 minus second L2. And I want to store these values in L3. Okay, so I'm going to force the calculator to take the differences of each of the sets, and I want it to store it in L3. Okay, so let me go back to my lists. I go Stat, Edit, and you'll now see that there are differences in L3. So you didn't have to do the individual work here for each pair. The calculator did it for us. Now what we need to do is a t-test, not on L1, not on L2, but on L3. So I'm going to go back to Stat, and I'm going to do a normal t-test. And I do have data. My difference, my mu 0 is going to be 0. I'm going to assume there is no difference between L1 and L2. But the thing that I'm going to do it on is L3. That's where all my differences are. Frequency is 1, and I'm going to assume that my H0 is equal and my HA is not equal. And I'm going to go ahead and draw it just so we can see what it looks like. Okay, our p-value is 0.019. Our alpha was 0.05. Therefore, our p-value is less than our alpha, and therefore I need to reject H0. But H0 was saying that the before and after equaled one another. So I can say we have enough evidence to support that the before and after for pain level is different. Now I can't say, I did not test to see if it was greater than, I did not test to see if it was less than. All I wanted to know is if it was different. And therefore I can say, hey, we have enough evidence to suggest that after hypnosis, there is a different pain level. Okay, so that's using the TI-84. You want to put your first values in list 1, second value in list 2, take the differences of list 1 and list 2 and store it in list 3, and do a regular t-test. That's how you're going to do it on an TI-84. Here's our example. A football coach team was interested in whether the coaches of the college's strength development class increased his players' maximum lift in pounds on the bench press exercise. He asked 4 of his players to participate in the study. The amount of the weight they could each lift was recorded before they took the strength development class. After completing the class, the amount of weight they could lift was again measured. The data is followed. The coach wants to know if the strength development class makes his players stronger on average. Let's record the differences. And then we want to make sure how we're taking the difference is going to be after minus before, because we want to know the difference, and if they can push more weight after, that should be a positive value. All right, so let's pull up the TI-84. And first of all, I want to clear out all my lists. So let's go ahead, stat, clear lists, and I'm going to clear all. So 1, 2, and 3, because I'll need all 3 of those lists. All right, now that that's done, let's go ahead and put our data in the lists. For L1, it's going to be the weight before, prior to taking the class. For L2, it's going to be the after they took the class, how much can they lift. Now in L3, I'm going to take the differences, but this time I'm going to do L2 minus L1, because if it's a positive, if they can now push more weight, I want to make sure that that is positive. So I'm going to get outside of my list area, and I'm going to say L2 minus L1. Now sometimes this doesn't matter, but in this case I really do want it to be, if they can press more weight, that value is a positive value. I am going to store it in L3. Okay, I'm going to do my test on L3. So stat, edit, go to tests, and t-test. Now I'm going to assume that there was no difference, but we want to know if they're stronger on average. So my list is L3 frequency, and therefore our average should be more than the 0 that we started off with, that 0 difference. And I'm going to go ahead and draw it. We are testing this against an alpha of 0.05. Well, P is 0.21. That is definitely greater than alpha. And because it is greater than alpha, we cannot reject H0. We cannot reject H0 when our p-value is greater than our alpha. And because of that, there's just not enough evidence to say that the strength development class helped the players get stronger on average. That doesn't mean that 1 or 2 students didn't get stronger. It just means the average of those 4 players doesn't reflect that there's enough evidence to suggest that the strength development class helped them make them stronger. Now I want to do that same thing, but using the website. So first of all, I need to change the two-tailed test to, hey, I want to make sure that my players are stronger. And if they are stronger, ours is stronger than theirs, but our H0 is going to be less than or equal to. So we are a right-tailed test, and I need to put in my data. All right, now that we have our data in, we just need to calculate it. Okay. Now remember, our p-value equals 0.2149, and therefore that is larger than our alpha, and therefore we can't throw out H0. H0 is accepted. H0 was, well, it's either less than or the same, because our test was an HA, that they were stronger after the test, after the weight training class. And because we can't throw out H0, that means HA isn't so acceptable. It's not as supported with evidence. So again, we're going to say there's just not enough evidence to say that they were stronger after taking the strength development class. Let's quickly run through another test, and this time I'm only going to use the TI-84 Plus. But again, that website is really cool. You just put your data in, very similar to the TI-84, but there's not an extra step. 7 8th graders at Kennedy Middle School measures how far they could push the shot put with their dominant writing hand and their weaker non-writing hand. They thought they could push equal distances with either hand. The data is collected and recorded. So using the TI-84 Plus, we are going to calculate subtracting the dominance hand and the weaker hand. So it's going to be dominant minus weaker in that calculation. First things first, I need to put my data into the list. So my lists have already been cleared out. All right, now that the data is in, I need to fill in the differences. So I'm going to run out of here and say the dominant hand was in L1. So L1 minus L2, the weaker hand, and I'm going to store it in L3. Beautiful. Now I'm going to run a t-test on L3. Okay, I'm going to assume my differences is 0. My list is in L3. It is a frequency of 1. It is where we want to say that our differences for age 0 is 0, equals 0, and our H alternative is our differences does not equal 0. I'm going to go ahead and draw it. Our alpha is set at 0.05. Our p-value is 0.07. Our p-value is greater than our alpha, and therefore we cannot reject age 0. And therefore, because we cannot reject age 0, we're going to say at a 5% level of significance from the sample data, there is not significant enough evidence to conclude that there's a difference in the child's weaker and dominant hands to push the shot put. Now again, per child there may have been a difference, but on average for all the differences of the children we tested, there is not enough evidence to suggest that there is a difference. Okay, that's it for this round. Until next time, be seeing ya.